Okay, shall I now? Okay, write the next heading, that is projectile motion. This comes into D. Okay. Earlier today what we have learned, S is nothing but Sx plus of Sy and V is nothing but Vx plus of Vy. Yes or no? Or similarly we can calculate over here by using what, under the root of Sx square plus of Sy square. This will provide you what, displacement. Yes or no? And this will if I calculate the magnitude again, then under the root of Vx square plus of Vy square will provide you what, speed. Yes or no? Okay, now let us come back to our point new, that is what, projectile motion. Now in projectile motion two things are happening simultaneously. The body is moving in x-axis as well as in y-axis. Okay, if the body is moving in x-axis as well as in y-axis, then can I say that the motion will be parabola? Yes or no? Consider an object is being projected with initial velocity u and it is making an angle theta with the horizon. Will that object continues in a straight line like this? No, no. So then the object will be landing like over here. So can I say that this is nothing but your projectile motion? This is the motion which is being represented by your parabola is known as what? Projectile motion. If the object is initially being projected with initial velocity u, then can I write over here along this x-axis, that is u cos theta, and along y-axis, that is what, uy is equals to u sine of theta. First thing, tell me, where is acceleration due to gravity acts? Along y-axis. That means at any point if I measure, acceleration due to gravity is acting in the downward direction. Yes or no? So acceleration along y-axis is always minus g and acceleration along x-axis is 0. If acceleration along x-axis is 0, then can I say that this ux value, that is u cos theta, will remain unchanged at any point. But the value of u sin theta changes with respect to height and time. The value of u sin theta over here will be different, over here will be different, and over here will be different. Now listen to me. Initially in y-axis, if we talk over here separately, initially in y-axis, what is your initial velocity? That is your u sin theta now. Along y-axis. And along x-axis is what? U cos theta. Okay, so velocity along x-axis is constant. Why? Because acceleration is here what? 0. That means there will no change in the velocity. And similarly, Sx can be calculated directly using u cos theta into t. Yes or no? But what happens in the vertical motion? The velocity which is along the vertical motion, this value changes. Consider this is your ground. Already we have learnt in motion in gravity, as the object goes in the upward direction, velocity decreases. Why? Because acceleration due to gravity, that is g value, is acting in what? In the downward direction. Yes or no? Velocity is decreasing because of acceleration due to gravity. Then can I say that at certain position velocity over here becomes 0? Yes. Then again velocity will be following this particular path, then the velocity increases. Yes or no? Okay. Similarly, can I say that when object is being projected in a projectile motion, along x-axis velocity is unchanged. Okay. But what is happening along y-axis? Y-axis is having an acceleration that is minus g. That means, can I say that when it reaches the half portion, that means at the maximum peak value, then can I say that at this point, this region or this height is called as Hmax, and at Hmax, velocity along y-axis becomes 0, but velocity along x-axis still remains same, that is u cos theta. Okay, the velocity at this point again always be different. Then over here, if I want to calculate the velocity, for example, this is the point where I selected and it took a time period, let's say t, then the velocity in y-axis is being represented by uy minus of gt. Can I write like this? Why? Because along y-axis acceleration is happening. Acceleration is there due to that velocity is changing. So can I say that in first region, let's say this is point A, this has your point B, and this has your point C. From A to B, velocity is increasing or decreasing? Yes, very good. So velocity along y-axis is decreasing, and again from B to C, velocity along y-axis increases. So can I write over here, A to B, velocity in y direction decreases, and B to C along y-axis velocity increases. Got my point? Similarly, can I also say that along x-axis always velocity is constant? Can I? Okay. So these are the basic things what you have to understand. Right on. Okay, shall I? So this is your projection and it follows this path. This is your x, this is your again y, 0 initial velocity u making an angle theta, and this portion is called as what? Hmax, and this portion is called as what? Along x-axis it is called as what? Range. Okay, ux is what? U cos theta, uy? Yes, very good. U sin theta. Velocity at this point. In x-axis, first tell me in x-axis. So Vx at this point is also u cos theta. Along this axis, Vy is equals to what? 0. Okay. And at any point, we can calculate velocity by using Vy is equals to Uy minus of Gt. Okay. Now, let us calculate what is the displacement happening in x-axis along in y-axis. Okay. From ground to ground. Let us calculate from ground to ground. If I throw in the object from here, after some time it hits the ground. Yes or no? Displacement along y-axis is what? 0. Whenever displacement is along y-axis, can we calculate the time also? Yes. So displacement along y-axis from ground to ground is what? 0. If displacement along ground to ground in y-axis is 0, then can I use Sy is equals to Uy t plus of half of Ay t square. Can I write like this? Displacement along y-axis is 0. So 0. Uy is what? Can I say u sin theta? So u sin of theta into time t minus of half of, can I write gt square? Can I? Can I also represent this as u sin theta into t is equals to half of gt square? One t and this t get cancelled. So can I write t is equals to 2u sin theta upon g? Did you saw this equation somewhere else? It's the motion in gravity. Yes, very good. So can I also say that if the object is being projected in vertical motion with initial velocity u sin theta, then can I get the same time period? 2u sin theta. What is our initial velocity? U sin theta. Substituting in, I will get the same result. Na? Yes or no? Right on. Okay, shall I? Let us have some example on calculating the time. Given that initial velocity is 100 root 2 meter per second, then this angle is given 45 degree. This is your x, this is your y, this is the origin. I will do one. Okay. Just now we found that it is nothing but 2u sin theta. Yes or no? So if I substitute in that equation that t is equals to 2u sin theta upon g, that is nothing but 2u. Can I write over here sin 45 degree? That means ux is equals to 100 root 2 cos 45 is 1 by root 2, and over here also 100 root 2 into 1 upon root 2, root 2 get cancelled. Yes or no? Or can I say that this u sin theta value is what? 100. That means t is equals to 2 into 100 upon 10. That is nothing but 20 seconds. Yes or no? This is how we generally calculate what? Time period. Right now. Consider the object is being projected with what? Initial velocity u with an angle theta. Can I say this region as Hmax, and at Hmax velocity in y direction becomes 0. In along x-axis Vx remains constant, that is u cos of theta always. Yes or no? So can I say that over here ux is nothing but u cos of theta, acceleration again is 0, acceleration velocity along uy लिखेंगे पहले, so uy is equals to u sine of theta. Yes or no? Now let us calculate what will be the Hmax. What will be the Hmax? To calculate the Hmax, we need to calculate what displacement along what y-axis, first thing. Second thing, or by using what Vy is equals to 0 over here. So can I say that by using this equation Vy square minus of Uy square is equals to 2Ay Sy. Okay. Now from here, what is the displacement along y-axis for Hmax? Yes, from here to here, that means from this is the displacement, from here to here is your displacement, or from here to here, but the height remains same, na? Yes. So finally at Vy, what is the velocity? 0. So what is initial velocity? That is minus of u square sine square theta, which is equals to minus 2g. Can I write over here Hmax? Can I also cancel this negative? Then Hmax formula becomes what? U square sine square theta upon 2g. Again I am asking you, have you seen this equation ever? Yes, height Hmax for vertical motion. Okay. Similarly, if I say again the question as if I throw in an object with 100√2 meter per second with an angle 45 degree, then the velocity over here is 100 and the velocity over here is also 100. That means u sine theta is 100, u cos theta is also 100. So can I calculate the Hmax? Then by using this equation, so Hmax is equals to what? Can I write 100 into 100 divided by 20? Can I cancel this 1s and 5? That means can I say that Hmax is 500? Yes or no? Point number 3, write the heading of range. Okay, to calculate the range, again I am coming back to the figure. If an object is being projected with an initial velocity u, this is your x-axis, this is your y-axis, then the object will be following this path. Yes or no? If this object is following this path, then this region is called as what? Your range, na? Yes or no? If this is your range, and we already know that ux is what? U cos theta. Here the velocity remains constant because acceleration is what? 0. Do we know the time value? Yes, we know the time value. The time value is represented by 2u sine theta upon g. Yes or no? Yes or no? Okay, if we know the time period, then means if an object is going in the vertical direction or in the horizontal direction, it will take the same time period. Just today we discussed that. Yes or no? That means can I say that range is nothing but that is your displacement along what? Sx. What is the velocity along Sx? That is u cos theta. If I say velocity is nothing but displacement upon time, then can I say displacement is nothing but v into t? Can I? Okay, so what is our displacement? So displacement, that is nothing but your range, and initial velocity along this one is u cos theta into time, and time value we have, and that is what? U cos theta into t, that is 2u sine theta upon g. Okay, can I also say that u sine theta, what is your u sine theta? Uy. Can I say this is your ux? So can I also write like this? Range is nothing but 2 times of ux uy upon g. Can I also write this as range r is nothing but u square sine 2 theta upon g. देखो ध्यान से, 2 sine theta cos theta is nothing but sine 2 theta, na? Yes or no? If I say, now listen to me, if I keep the initial velocity constant, for example, if I consider 100 meter per second, if I throw with 60 degree, if I throw with 70 degree, if I throw with 45 degree, if I throw with 30 degree, where can I get the maximum range? Where can I get what? Maximum range. Then if u and g are constant, then only the variable is theta, I am saying, na? Yes or no? If theta is the only thing which is variable, then can I write 2 theta is nothing but some value, and where sine theta becomes maximum? At 90 degree, yes or no? At 90 degree, what is the value? 1. So can I say that for maximum range, can I write 2 theta is nothing but 90 degree, or theta is equals to 45 degree. If I keep the velocity, for example, 100 meter per second, if I throw the object at 45 degree, I will be getting the maximum range then and then only. If I throw at 60 degrees, same initial velocity 100, then I will not getting the maximum range. For maximum range, always use what? 45 degree, you will get the maximum range. Got my point? Right on. Okay. Let us have some example on our range. What is our range formula? Just we have calculated, that is ux2 ux uy upon g, or this can also be written as 2u sine theta cos theta, u cos theta upon g, or this can also be written as u square sine 2 theta upon what? G. Okay, now considering one example, object is being projected with 100√2 meter per second with an angle of 45 degree. You want to take the different velocities and different angle, different something you can use over there. Are yes or no? Okay, now if 100√2 meter per second and the 45 degree, can I write over here, that is your ux is nothing but u cos theta, and substituting the value I will be getting what? 100 meter per second. And similarly in y-axis, uy is equals to 100 meter per second. I got my point? Okay, substituting in this equation, that means 2 into, can I write 100 into 100 divided by 10. Can I write like this? Can I cancel this 1 0 and 1 0? That is nothing but 2000 meters. Okay, this is how we can calculate what range, Hmax, and the time period. Okay, right on. Okay, the fourth heading is velocity at time t. Okay, now listen to me. Everyone, now listen to me. Consider an object is being projected and it falls over there. This is your x-axis. We know that this is your y-axis. Let's say it is being thrown with 100 meter per second, 100√2 meter per second, and again the angle is 45 degree. Okay, we already just now saw how to calculate Hmax, how to calculate time, and how to calculate what? Range. So now we are not calculating that. And in this equation, what we got? The time period 20 seconds. That means, can I say that object will be at Hmax in 10 seconds? So at Hmax, time period will be 10 seconds. Why? Because total range we are getting what? 20 second time. And what is the range we got? 2000 meter. Okay. So this is your 2000 meter range. What is your Hmax? Okay, 500 meter. So this is your Hmax 500 meter, range is what? 2000 meter, and time is what? 20 second. Obviously, already we know that velocity at Vy, that is Hmax, becomes 0 and velocity along x-axis never changes at all. Yes or no? The question is, let's say, find the time period at 2.5 seconds. So I want to calculate the time period over here, that is t1 is equals to 2.5 second. Similarly, तो कितना हो रहा है देखो रे 2.5 means 10 ना, 10 means 7.5. Calculate also over here. Here the time period will be T2 will 17.5. Okay. Now everyone will listen just me. Now the question is what? Find out the velocity. Question is find out the velocity at time t is equals to 2.5 second and 17.5 second. This is the question. We can calculate that. We already know that either in 1 second, 2 second, 5 second, 10 second, or at 20 second, velocity along x-axis never changes. Yes or no? And velocity along x-axis is what? Ux we got 100. Yes or no? And velocity along, initial velocity along y-axis is ux is equals to 100 meter per second. 100 meter per second. But uy changes. Uy always changes, and at this point it becomes 0. But we don't know what will be the velocity here. Yes or no? So can I say that if I want to calculate, then I will be calculating velocity is equals to nothing but Vx plus of Vy. Or if I want to calculate the magnitude of this v, then I have to use what? Vx square plus of vy square. Can I say this is your speed and this is your velocity? Yes or no? Okay, now listen to me. Shall I? Vx is what? Vx at any point is nothing but ux, and that is always remains 100 meter per second. Yes or no? But velocity along y-axis changes. It may be 2.5 second, it may be 10 second, it may be 7 second, whatever the time is given. Okay, then Vy at 2.5 seconds. Vy at 2.5 seconds. ऐसा नहीं लिखता रे भाई. Vy at t, and t here is 2.5. Okay, at any time t. Then over here I should be writing what? Vuy. We are having one equation now. So Vy is equals to uy minus of gt. Are yes or no? I am using this one to calculate what? Velocity at any time t. Why? Because in Vy direction we are having acceleration, then we have to use this only. I got my point? Okay, so if I use that, then I will be writing uy is equals to, uy minus of gt. Okay, time period is given 100. 2.5 seconds. So initial velocity is what? 100 minus of this 10 into 2.5. Then can I say that this is 100 minus of 25, that is nothing but 75 meter per second. Okay, so what is the velocity at 2.5 second? Can I say over here 75 meter per second? Yes or no? Definitely after 5 seconds it will become 50. Maybe 50. Yes, 100% na? Okay, thank you. So over here to 25, over here 0. This is how the velocity is decreasing. Now, if I want to write this in vector form, then I will be writing velocity is nothing but Vx plus of Vy na. Vx plus of Vy. So velocity is nothing but Vx, that is what? 100 I cap plus of, this can be written as 75 g cap. So this is your velocity along x-axis, this is your velocity along y-axis. Similarly, if someone asks you the magnitude of this one, then I will be using this equation to calculate what? The magnitude. So can I say V is nothing but under the root of 100 square plus of 75 square? Are yes or no? So calculate this and tell me. So V is equals to how much? Calculate fast. करते तुम लोग. 75 into 75. कितना? Okay, so V is 125 meter per second. So whatever this value is, after substituting, she got the answer. That is what? 125 meter per second. Check yourself. So this is how we can calculate the speed. So this is the speed of the body. Okay, this is the velocity of the body. Got my point? Magnitude of velocity is nothing but a speed now. Yes or no? So this is the speed, this is the magnitude of velocity, and we can also calculate what? The angle by using what? Tan alpha is equals to what? Or tan theta. Alpha le lo naam iska. So let's say it is making an angle at this point along the horizontal always. Alpha is the angle always along the horizon. I got my point? Tangent and the horizon. So tan alpha is equals to Vy upon Vx na. Are yes or no? So what is our Vy velocity? That is 75 upon 100. Then can I say that is 3 by 4. Tan of 3 by 4 कब आएगा? Tan 3 by 4 37. So theta is equals to 37 degrees. Are yes or no? This is how we can calculate velocity at any time t, or we can also calculate at this value also. If I substitute over here, then that is what? 17.5. That means this becomes what? 175. If I subtract this, this becomes negative. Obviously this comes in negative. Why? Because this is your tangent velocity and this is the what? Vy direction, and this is your Vx direction. Okay, just now I told you that alpha is what? The angle between what? tangent and the x-axis. So can I say this is the axis? Now it is in the downward direction at 17.5. The velocity will remain. Still the velocity equation will come 100 I cap minus of 75 j cap. Okay, substitute and get the answer. Why? Because already when I am substituting the value now, I subtracted 7.5 here and added 7.5 here. Definitely the velocity at point A and at point B, if on the same range, both will be having what? Same velocities. Okay, but in the opposite direction. Over here from A to B, that means from A to Hmax or origin to Hmax, velocity will be positive and angle is also positive. And from Hmax to this particular point, that is ground, velocity and angle both will be negative. Okay, over there from Hmax to ground, you will be getting always theta negative. That is what, for example, at 17.5, you will be getting minus 37 degrees. Okay, and the velocity still remains same. That is 100 I cap minus of 75 j cap. Okay, calculate करके देख लो. If you want me to calculate, I will. So Vy is nothing but Vy is equals to Uy minus of Gt. Applying the same equation, initial velocity is 100 minus of this 10, that is 17.5. Yes or no? And this becomes 175. And if I substitute, Vy is equals to 100 minus of 175, that is what? 75 with negative sign. Yes or no? Definitely your V value over here, if you want to write, V is nothing but 100 I cap minus of 75 j cap. Substituting this in the same form, you will be getting the velocity again 125. Why? Because we are calculating the magnitude, and angle will be minus 37 degrees. Got my point? Write down now. Okay, shall I? Continuing that part, so V can be written as Vx plus of Vy, and the magnitude can be written as nothing but Vx square plus of Vy square under the root. Yes or no? Just now we saw this. Or this can also be written as V is equals to Vx, and Vx can be written as U cos theta I cap plus of Uy sin theta. Sorry. You want to write Uy, ऐसा लिख देंगे Uy minus of Gt. Okay. Similarly, and the magnitude can also be written as magnitude is equals to under the root of U cos theta whole square plus of Uy minus of Gt whole square. From here we can also calculate what? Distance, and distance can be calculated using what? Distance is equals to magnitude of velocity dt na. Why? Because velocity is nothing but displacement upon time, dx upon dt. Yes or no? If I write like this, dx is equals to v dt, we should be integrating this now. But I am saying this time the magnitude, that means I have to write like this now. Yes or no? This becomes what? Distance. So distance is equals to, this equation provide you distance, not the displacement. So distance is equals to magnitude of integral magnitude of dt. Or if you want to expand this, you can expand also. So distance can be written as integral of magnitude of what? This one under the root of U cos theta ka square plus of Uy minus of Gt's square dt. Okay, this is how we can calculate what? Distance. Okay, all you need to substitute the values now. Okay, right on. Okay, shall I? The next thing is, next heading, velocity at any height h. Now, for example, stop writing and now listen to me first. This is your projection, and initial velocity, let's say u, this is theta, we already know this is ux, uy, this is your hmax. Okay, now if they don't provide you time, they can provide you height. Calculate when the object is at certain height. So let's say this is the height, whatever the height is, either here, and this direction positive, in this direction also height remains positive. Now, how generally the things changes? Velocity along x-axis changes? Never. So Vx is constant always. So Vx is always Ux and this value is always constant. We already know that. So nothing to do with this. But Vy is changing. If Vy is changing, then I will be using for the height is nothing but Vy square minus of Uy square is equals to 2g. Can I say any height h with a negative sign? Yes or no? So if I want to substitute, that means Vy square can also be written as Uy square minus of 2gh. Can I? Or can I also remove the this one value, then I can substitute the square. I got my point. And Ux is Ux only. So Vx is what? Ux. If someone asks you tan alpha, so tan alpha can also be written as, that is Vy upon Vx, and over here Vy is nothing but under the root of Uy square minus of 2gh upon what? Vx. That is your Ux. Are yes or no? Shall we do an example now? Okay, write down. Okay, shall I? Example on velocity at any time, velocity at any height h. Consider object is thrown, let's say 60 meter per second, making an angle 60 degree. It will go here. Hmax I don't know. Question is, find velocity at height 55 meters. Shall I one? Okay. Then you have to do one more. Okay. So initially Ux is what? U cos of theta, and U is what? 60. 60 means half. That becomes 30 meter per second. So velocity along x-axis is 30 meter per second. Similarly, calculating over here, that is Uy sine, is equals to U sine of theta, and this is 60 degree, that is root 3 by 2, 30 root 3. So Uy is equals to 30 root 3 meter per second. Okay, these are the two values we got. Now Ux is Ux only, na? So Ux unchanged, that is 30 meter per second, but Uy changes. So Vy is nothing but under the root of Uy square Uy square minus of 2gh. Yes or no? Now substituting the value, or you can also write this equation as under the root of Uy is nothing but U square sine square theta minus of 2gh. Whatever you wish you can write. So Vy is equals to, substituting the value under the roots. So Uy 30 root 3, that is 30 into root 3 square minus of 2 into 10 into 55. Calculate these values fast. So Vy is equals to under the root of 30, 900 into 3, 27. And minus of this becomes what? 100. Okay. So Vy is equals to how much? 1600. And Vy is equals to 16 means this becomes 40 meter per second. So what is the velocity along y-axis? 40. What is the velocity along x-axis? 30. Then can we calculate what is the velocity? That means under the root of 30 square plus of 40 square. Yes or no? So if I calculate that velocity under the root, this becomes 900. And this becomes 1600 and 16,925. That means V becomes 50 meter per second. Can we also calculate theta at this point? Let's say wherever this is, either here, I don't know. You have to calculate the Hmax. So consider I got here. Then can I say this is your Vy and this is your Ux and this is your V. And what we got, V is equals to how much? 50 meter per second. At this point Ux we got 30, and at this point Uy got V 40. And can we calculate this alpha? Yes, we can calculate the alpha. Alpha is nothing but tan of alpha is nothing but Vy upon Vx, and at this point Vy we got 40 upon Ux 30. That means 4 by 3 in tan 4 by 3, that means 53. So alpha we got 53 degree. Are yes or no? Similarly, we can also write this equation in the form of vector, and if we are writing in the form of vector, then v can be written as, that is your u of what, ux and vy, sorry, v is nothing but vx plus of vy, yes or no? And vx at any point remains u cos theta, that is what I cap, plus of, and uy, and what is your uy, that is what, there, over there. Okay, substituting that value here and add j cap. Are got my point? Are beta under the root of u square minus 2gh na. Substitute, you will be get the value of ux, sorry, vy. Okay, the next heading is find the coordinate. They can ask you find the coordinate of body at any time t. At time t. Any time t. Okay. Now, generally to find the coordinate, we can use what, s is nothing but sx plus of sy. Yes or no? Yes or no? Sx. What is the velocity along x-axis? Arey beta, velocity along x-axis is always constant, uxc. So sx can be written as u cos theta I cap into t I cap, and plus of this value changes with respect to time. That means u is equals to s is equals to uxt plus half axt square. ऐसा formula होता है ना. S is equals to ut plus of half of at square. Only in y changes, so uy, and this becomes y, and over here you get a negative sign. Substituting this value over here, then can I write what, uyt, or uy can also be written as u sine of theta t minus of, can I write phi t square? No, generally write half gt square only. Okay, so this is your along x-axis and this is your along y-axis. Can we find the coordinate? Yes, we can find the coordinate by using this, and we can also find the displacement. For displacement, if they ask displacement, for example, this is the projectile from A to B. A to B. Distance we already know how to calculate. Distance can be calculated using what? Integral v of magnitude dt na. Yes or no? Just I told you this equation. Now if they ask you the displacement, find out the displacement, then the displacement equation can be written as s is nothing but under the root of x square plus of y square, that is your sx and sy. Okay, I got my point. But before that you need to calculate sx and sy. Okay, now let us try to understand this. So sx is also done. Sorry, this one is your sy. This one is your sy, and this is your sx. Okay, substituting any equation, let's say the value is 50 meter per second. Let's say initial velocity is 50, u is equals to 50 meter per second, and let's say theta is 37 degree. Calculate coordinate. Calculate coordinate at any time t. Take t 1, 2, 3, 5, 10, whatever you want to take, you can take. So if I want to substitute the coordinate, then if I am using for sx, I will be using what, u cos theta into t. Can I calculate time for 4, 5? 5, le lo 5. So t is equals to 5 seconds. Okay, now sx is equals to, u is what, 50. We already know that theta is what, cos of 37 degree into 5 seconds. That will provide you the coordinate for sx. Where is the point along the x-axis? And cos 37 कितना होता है? 4 by 5. So 4 by 5, 5 ones are 5 tens are, that is 40. 40 into 5, that is 200 meter. So what I got, sx is what? 200 meter. And similarly we can calculate sy by using what, that equation. What is this equation over here? U sine of theta into t minus of half gt squared. So substituting over here, and sine 37 is 3 by 5, that means 5 ones are 5 tens are, that means this becomes 30. No, तो बोलो कितना हो रहा है? अच्छा, 30 for this. Okay, 30 into time period is for 5. Time period is 5 minus of this becomes 5 into 25. Substitute, that means 150 minus of 125, that means 25 meters. So the coordinate is 200 comma 25. So we can find anything if we have the concept. Are yes or no? So today we have started the projectile. Till here we reach now. Okay, 15 minutes I will complete energy also. Okay, complete this. Okay, shall I? Next point, they can ask you what? Find out the average velocity of projectile. Now listen to me. For example, this is your A, this is your B. Okay, if they are asking the projectile for A to B, if they are asking what? Projectile from A to B throughout the projectile, then can I say that what is the displacement here? Displacement is nothing but your range. And what is your range? That is what? U cos theta into t na. Yes or no? That means, can I say average velocity can be calculated from final velocity minus initial velocity upon time. So V average is nothing but V final minus of, sorry, not V final, X final minus of X initial upon time. Yes or no? What is your final position? Final position is U cos theta t minus of 0 upon what? T. That means 0 tt get cancelled. So throughout the projectile, V average is nothing but U cos theta. Okay, but they can ask at Hmax. They can ask here. They can ask anywhere now. Then, for example, Hmax. Then means, can I say this is your displacement? Let's say this point is C. How to calculate this displacement? We already know this. How to calculate that? So S can be calculated using, just now we saw that Sx square plus of Sy square. Yes or no? So this is your displacement. Displacement upon time is nothing but your average velocity. So can I say that V average at any point can also be calculated using what? Under the root of Sx square plus of Sy square divided by time. I got my point. If they are asking for a projectile throughout the range, we can calculate. They can ask at any point and we know how to calculate that. And you know value of Sx and you know value of Sy. Substituting in that, you can get anything. So remember general equation and for ground to ground. Okay, right on. Okay, shall I? Just 5 minutes. Okay, shall I? Write the heading, only 5 minutes. Energy of projectile. Okay, this is your projectile. What is H here? 0. What is H here? H is equals to 0 here. H is also equals to 0 here. Over here, H is equals to H somewhere. Over here, H is nothing but Hmax. Are yes or no? We know everything to how to calculate H, where to calculate H, at what time we need to calculate velocity. We know everything now. So this is your range. We don't want. Consider 1 kg object. Mass is what? 1 kg. Okay. What is the kinetic energy here? Not thrown yet. Initial velocity consider 0. What is the kinetic energy? 0. Potential energy? 0 on the ground. Now I thrown. Potential energy? 0. Kinetic energy? Maximum. Why? Because here we will be having the maximum velocity. So at this point, kinetic energy is what? Maximum. Are yes or no? Now, kinetic energy can be solved in two forms, s-axis and as well as in y-axis. Why? Because velocity in both the directions are different and y-axis always changing. Are yes or no? So can I say that kinetic energy in y-axis is nothing but half of mv square, vy square. Okay, but kinetic energy in x-axis is always constant, that is half mvx square. So no need to do anything with this. Yes or no? Always substitute the velocity along this x-axis, get the answer. But along the y-axis, it always changing. So kinetic energy along the y-axis is nothing but half of m of this vy squared. Vy squared can be written as uy minus of gt square. I got my point. Or kinetic energy, if you want to elaborate that, half times of mass, this can be written as u square sine square theta minus of gt's square. Okay, potential energy here 0, potential here energy is here maximum. So can I say that at any point in generalizing, total energy is nothing but potential energy plus of kinetic energy along y-axis plus kinetic energy along x-axis. Okay, you know MGH, you know this equation now, you know that equation also. Substituting where they are asking, at what time they are asking, at what height they are asking, at what coordinate they are asking, you know everything to substitute and get the answers. I got my point. That's it. Now you can go.